Great. Okay, so hopefully everyone can see my screen. I guess this is a test case, so I'll just copy this over, but this could be anything, so this isn't as important for us right now. I'll do it in REPL because I think it's a bit cleaner just to see code. Okay, so yeah, this looks about right. Okay, cool. So, okay, so I'm missing one more. Okay, cool. All right. Okay, so who wants to kind of walk me through what their thought process was for this problem, and I guess we can kind of just try to code it together up as a group, and see if it kind of see where like the kind of where we made assumptions that may or may not kind of hold, right? I guess in terms of how the problem is or how the functions are going to be running. So the function starts. It's just called get longest name. So I'll just write that. It takes in, we'll call it an object. Okay, and so what's like the process that we want to think about for doing this problem here? Anyone at all? Any takers?
Like look at a name, set it to something, look at the next name. If that one's longer than the first one, then reset the first one and continue to do so.
Okay, so let's look at it. Okay, so let's get the. So what should I do here? I'll just say get. I'll call it longest name. Okay, and I'll set it equal to what? I'll set it equal to empty string initially. Okay, and then you said I guess eventually we're going to return longest name, right? And like this may seem kind of trivial, but like essentially this describes your entire function, right? Of what it's trying to do, really, right? The entire function is say, hey, let me set the longest name to something. Somewhere in the middle, I'm going to edit longest name, and then at the very end, I'm going to return longest name. And I think one of the good and pros and cons of kind of us showing a lot of practice problems that all look the same is that I think a lot of times people just start copying code over, and maybe they're not like quite like kind of internalizing what we're trying to do here, right? Like fundamentally, like what we're trying to say is every single time we run get longest name, the contract or the expectation is I'm going to give you an object, and you're going to give me the longest name in this object, right? And the point of recursion is that like you don't care about like what's happening kind of outside of you. If someone gives you an object with only one name in it, like you just check that one object. Like that's it. You don't worry about anything else that has been explicitly given to you. Okay. And so with get longest name, every time I'm calling it, I'm clearly going to be feeding it an object. And then every time I call get longest name, I'm expecting the return value to be a string value. Okay, two very important things that it's going to really kind of trip us up if we don't or if we're not super clear on that being like the contract, if you will, of the function. Okay, so if we use and then I think Zach said the next step was let key. So we're going to go through our object, right? Okay, and then if let's say our object was just straight up all key value pairs, right? Everything was a string. There was no nested objects. How will we do this problem? Anyone at all?
We would let longest name equal key.
Okay, let. Okay, well I guess.
Let, but just reassign it.
Okay, equal key. Why?
To give it a test case or to give it like the original. Because like regardless, then we're setting it, and then it will just return that one.
Okay, so then
Yeah.
but this is embedded in a for loop, right?
Well, we have to do a let current name equal key.
Okay, so it's not longest name anymore.
Longest name equal current name, I guess.
So let current name equal key, and then longest name equal current name.
Yeah.
Okay, so let's say I call this, right, and let's say my object has 4 keys in it. This is going to run 4 times.
Then we need to compare the longest name to like the next one, which is where we got hung up on like how to compare. Not how to compare, but how to set the two names and then continually run it through a loop.
Okay, so let's take that one step at a time. How do we compare two names?
Their length property?
Okay, so spell it out for me. How do we do that?
The length of one. Oh, well, now those variables are gone.
Yeah.
I was just gonna say one of them dot length is greater than the other.
Okay.
If key is greater than longest name, then reset longest name as key.
Okay, so so if key is greater than longest name, then what?
Key longest name dot length.
Okay, key dot length. Then what?
Longest name is equal to key.
Okay. Everyone clear so far?
Yeah.
Yes.
Okay, great. So what we've done here basically is now we're saying before we start, let's always check the key, right? Because we know the key is always going to be a string. And so the key is always fair game for us to compare to the longest name dot length. And if for now we'll just say that if you have two strings that are of equal length, we won't make the change, right? We can easily adjust that if we want to down the road, but for now we'll just make the assumption that if two names are of the same length, we'll just keep the original one. Okay, cool. So if key is longer than longest name, then we update longest name to equal key. All right, you're typing loud, Lauren. So tell me what's going on. What's our next step?
Oh shoot! I thought I had muted myself. I was writing down what you just said. Remember it.
Okay, well I'll still ask you what the next step is.
I don't know because I was trying to write down what you had said.
Okay, so I have an object. I'm trying to check a key value pair. I've just checked the key. So what's my next step here?
I'm sorry, it's noisy where I am. I mean, I guess you've.
So in the key value
So
pair.
now the key now the longest name should have the longer of the two. It seems like.
Right, so I'm trying to check longest name against both the key and the value. I've just checked it against the key, so what should I be doing next?
You should return whichever is longer.
Okay, so what does returning mean?
Usually typing return and then the name of the variable that you want.
Okay, and does that end the function?
I'm sorry, does that what?
End the function.
Does it end the function?
Yeah.
I don't know. Not necessarily. Well, I don't know if there was going to be like an else statement. I guess it does. Sounds like you want it to end the function. Sounds like it might end the function. But the truth is, I don't remember. So.
Sure. And I guess this is something that's very key to remember for like any interviews or any practice problems. A return will always end the function.
Okay.
There's no, and like it's a very, very kind of hard and fast rule of programming that return anywhere in the function means you're done with the function. The code will stop right there. Nothing after the return will ever run. So like when you say return, that tells me, oh, great, I'm done with the function, right? And clearly, there's a lot for me to do still.
Okay.
So Greg, what's my next step here?
Oh, I think we need to check if the key has any lower. To check if the key, so the first thing we'd put in there is our family object. So we basically, name would be Lottie Cook. Now I want to check Laura Montano.
Okay, so the key is just a string, right? The key has no lower things.
You need to recurse into the object if the key is an object. You need to do if object dot key, although key in brackets is equal to an object, then we need to recurse.
Right. I guess
I agree.
sure. I mean, I guess going back to what I asked Lauren earlier, right? I want to check everything in family, right? This is a key, and this is a value, right?
Hmm.
So I've just checked the key, and so I guess what I was trying to get someone to say was, well, now we're gonna check the value.
Oh.
Make sense? We've checked Bloody Cook in this example. That's a key, and so we've already, whether or not key is longer than longest name, we've already kind of handled that, right? Now our goal is to check to see, great. Now let's check against the value of this key.
Okay.
Emma, Reina, Emily, make sense?
Yes.
And that value is an object.
In this case, the value is an object, but as we see here, it may not always be an object, right?
Okay.
Okay, great. So, Reina, what's next? If I know I'm gonna check against the value, how do I start doing that?
So sort of what Zach said before, that you need to test if it is if it is an object within the within the existing object that you're looping through.
Okay, say that one more time.
Basically, we have to sort of loop through the object to see if there's like a nested object within, like a child within the parent name.
You said loop through the object?
Yeah.
Okay, so we're doing that here, right? With our for and loop?
Yeah.
So what's next?
How do we get the value of an object? What is it? Key square bracket? Can we compare longest name to the value? But I don't know. I'm looking up how to access the value of an object. I don't know.
Yeah.
Emma. Oh, sorry. Go ahead, Reina.
Yeah, it would be like object brackets. Right.
All right.
Finish that thought, Emma. Sorry, Reina, finish that thought.
To access a value within an object, you would use the bracket notation.
Okay, so how would that look?
Like obj, and then the bracket.
Key?
Is that right, Reina?
Yeah.
How sure are you?
Well, the key is not very sure.
Sure. And so I guess like as we go through this, I'll just kind of give you guys some like quick notes of like things that you just kind of need to memorize or have to know for any interviews or practice assessments. This is how you access the value of a key in an object, right? In this case, if the object is called obj and the key is represented by the variable key, then obj open bracket key close bracket, it's the way you access the value associated with that key. Okay, kind of another hard and fast rule. This gives me value, but it's not enough, right? Like, what do I need to do with that value here?
You need to set it equal to something, like let current value equal object key.
Right. I should be storing it somewhere, and so this is a part where it's like I don't technically have to do this. I could just call this every single time, but after a while it gets repetitive, right? And it's unnecessary. But so by storing it in a variable called current value, I'm now able to just use current value everywhere. It's a little bit easier to read and understand kind of what I'm doing with the code here. Okay, so now I have current value. What's my next step?
Check if that's an object.
Sorry, say one more time.
Check if the value is an object.
Okay, so how did you do that, Emily?
So on the next line,
Yep.
You do if in parentheses type of current value equals and then like in quotes the word object, and then then we need, that's how you check. So then to right below that we need another set of curly brackets. So yeah, and then if it's an object, I think then we're going to need to call get longest name again.
Call get longest name here, you said?
Yeah.
Okay. Ooh.
But yeah, from there I'm not really sure.
Why do you think we need to call get longest name?
So that we can check, because if the value is an object, then we're going to want to check the key against longest name and then the value all over again.
Right. Okay, so we're on line 10 there, we call get longest name. And what are we passing into get longest name then?
Current value.
Okay. Great. And so let's say we're here now. What does that get us? So let's use a real example, right?
Mm-hmm.
This is current value if we just go through the first key value pair, right?
Yeah.
Luddy Cook was the Luddy Cook was the key, and then this object is the value. So when I pass in this object into get longest name, what do I get back? Or what should I be expecting to get back?
A string.
A string. Why?
Because on line 14 we return longest name, which is a string, and so we should expect the same from the function which we call in line 10.
Great. Okay. So can anyone give me kind of rephrase what Emily said? Not that Emily's wrong, but just to make sure that like people are really understanding this. What does this actually get me here when I call get longest name and I'm passing current value?
It should give you Laura Montano, right?
No. So I'm not really looking for like the answer. I'm just looking for like what like the like conceptually what is it getting? Like what is it doing, and then what type of, or not what type, but like what is it trying to return to me?
It's trying to return to you the longest name of those keys.
Okay. And by keys, which keys are you referring to?
Luddy Cook, Laura Montano, Laura Montano and John Drury.
Cool. Is it checking Deborah Gore?
Not yet. Well, it will as it recurses further down the function.
And will it?
Not if we don't return something.
As the way this code is currently written, are we returning something? This is our function right here.
Yeah, it's just going to return the longest one out of all of those.
So is it going to recurse right now as the way we have it written?
Yeah.
Okay. All right. So you said no 30 seconds ago, but now you're saying yes.
I'm thinking about it further, and it will continue to recurse because it's just going to keep on running the current value if the current value is an object, and there continues to be objects.
Victor, does that make sense?
makes sense to me, but I know it's wrong.
Okay.
Like, to
Oh,
me,
Sorry.
we'll go back to line 4 from there.
Sure.
We'd have to store it
Yeah.
to do something with it.
Okay, so actually what Greg said there I think is actually really important. And not to pick on Greg, right? Greg said it goes back to line 4 once I call it recursively, right?
Doesn't it? Good.
Is
It
that,
goes back.
is that what you said, Greg? Just to make sure I'm not putting words in your mouth?
Yeah, that is what I said.
Okay. Why is that not true, Greg?
Well, I mean, I guess what Zach just said, we'd go to line 2, but I don't know why it's not true. That's what I think is true. I don't know.
Right. If I was to say, hey, let's call get longest name, right? Where does it start?
Line 2.
Line 1, really, right? Like, when I call get longest name here, it's not going to say, all right, let me just jump halfway up the function I'm currently in. It's going to say, let me start a brand new function, right? Here, remember, here in this case, I'm going to put a comment here, and I'm not going to put the whole thing because it's really obnoxious. But let obj is equal to what? Obj is equal to family, right? When I recursively call this function and I call get longest name, I pass in current value, it's almost like I'm restarting this function again from scratch down here. But now obj is no longer family. Obj is whatever its family index of Luddy Cook. Right? And this is a super important distinction here, right? I am not keeping in this iteration my function and just jumping halfway up. I'm starting a brand new call of get longest name with a brand new value for obj, a brand new empty longest name, and now I'm going to restart this process all over again.
That makes sense. How can we skip resetting longest name to nothing and keeping longest name as Lottie Cook in our example?
That's a really great question, and it kind of gets to like the heart of recursion, right? We actually want to reset longest name, right? Because remember what I said, the point of recursion is that we solve a small problem. We're not trying to solve the entire problem. Okay? And so if I give you, let's say we start here, right? Let's say we start with the family value here, right? If I give you family, this entire family object and I pass it into get longest name, it is the responsibility of that call of get longest name to give me the longest name out of all these keys, right? If, for example, I would only gave it this object and called get longest name with this object, it is the responsibility of that call to get me the longest key out of these 4 values. It doesn't care what existed before. Right? Like the way that this recursion is actually working is first we say, all right, I need to get what the longest name in this massive object is, right? And then the way we do that is by saying, okay, well, let's take it step by step. What's the longest name in this object here? And then someone else says, well, to figure that out, we need to know what the longest name in this object is here. And then to figure that out, then we say, well, I need to figure out what the longest name in this object is here. And so at every single step, we're solving a smaller and smaller problem all the way until we get to here. And at this point, there's no more nesting, right? I just have three strings here. William Rhodes, Paul Nell, and Samantha. Okay? There's no more nested objects. And so I can very clearly tell you what the longest key in these 3 names are, right? In this object is here that I've highlighted. And if I tell you what the longest name in this object is, and I give you back the answer, now the person or the call that asked me for this can say, oh great, let me compare the longest name in this object with the longest name in this object, right? And we can, and let me just highlight, we'll say here, okay? We can now compare the longest name out of these 3 with Nina Rome and we're going to get back only one answer. And that answer is going to tell us what the longest name in this object is, right? Once we have that, we can then compare it to, actually, so let me just do it here, okay? So let's just take, like, let's just assume we did a recursive call and it went in super deep, right? It went from family to this object, which recursively called to this object, which then recursively called to, I got my indentations off, but this object, we'll say, right? And then that recursively called to this object. And at this point, we no longer need to care about recursion anymore because it's an object with only three strings, right? And no nested objects anymore. So at this point, I can say, out of these 3 keys, which is the longest one? And the answer is, well, Sir Paddington IV is clearly the longest one, right? It's longer than William Rhodes and Paul Nell. Everyone agree so far? Right?
Yeah.
If I'm looking at just this highlighted object here, it's clear that this Sir Paddington IV is the longest key here. Everyone good?
Yep.
Great. And so at this point, in order to solve that question, what I've done is I've called get longest name on just this object here, right? And that call of get longest name is going to say the answer is Sir Paddington IV. Okay, that's it. That's your answer. Okay. Now, oh, well, this is a very long name, so I need to like. Okay, great. Okay. Now that's going to give me the answer. And now the answer is to say, okay, well, between Nina Rome and Sir Paddington the fourth, which is the longest name? And the answer is going to be, well, Sir Paddington the fourth is clearly the longest name. And so we're going to say, okay, great. Let me get rid of that then, right? And now within everything inside this inner object, Sir Paddington the fourth is clearly the longest name. And so whichever iteration of get longest name was trying to figure out this object will figure out that this is the longest name in that object. And it will say, based on the data you gave me, this is the longest name that I have. And it's going to give back the answer. Whoever accepts that answer, it's now their role to compare that to Beverly Marquez, right? And between Beverly Marquez, Deborah Gore, and Sir Paddington IV, right? So everything inside this object, that function calls and say, well, Sir Paddington IV is your longest, right? And so we can actually just say, great, out of that object, Sir Paddington IV is the longest. Now let's compare it to John Drury and Laura Montano. And we're going to figure out that Sir Paddington IV is still the longest in this object. And then last but not least, we're comparing it to Luddy Cook. And we'll say Sir Paddington IV is longer than Luddy Cook. And now we've kind of boiled this answer up all the way from the very bottom to the very top. And we say, okay, in this family object, Sir Paddington IV is the longest name.
I just got to figure out how to write that out in code. Like when you that makes sense to me for sure. I just kind of putting that logic into JavaScript is the hard part.
Yeah, the other thing I'll say is also just that generally speaking, and when you're first learning, it's a little bit different because there's a lot of like syntax things that kind of trip people up, like yeah, I forgot a comma, I forgot a bracket, how do I write this? But as you get more experience in kind of writing the syntax, it's almost like kind of the way you write English, right? Like once you're let's say proficient at writing very basic English, like the like knowing how to spell words and put periods is not the hard part. The hard part is kind of knowing like what you're gonna write, right? Like having the thoughts and organizing it in a way that makes sense when you put it on paper. And I would argue that that's actually the same problem that we see in programming too, right? Is that it's actually so much more important that like you have a clarity of thought on what you're going to be doing before you start writing. It's almost like building a building without like a blueprint. Like you can say, all right, I'm going to start stacking bricks here. And I really hope that by the time I'm done, it becomes like a house, right? Versus, oh shoot, can everyone hear me still?
I hear you.
Okay,
Yep.
great. Sorry, the thing just
Yep.
went away. Yeah, sorry. I was saying like it's really important that like writing the code actually will not be the hard part for you eventually. it will be actually understanding what to write and understanding and thinking through the logic of this. And so here I'm just gonna undo this so you can kind of just go back and see all of this again. And I'm just gonna wrap us up because I know we went way over, but hopefully you guys found this helpful. Here when I do get longest name, what I'm doing is I'm saying, hey, I'm gonna give you this nested object, and I just need you to tell me what the longest name in that nested object is, right? And if I do that, that means I absolutely 100% want to reset longest name to blank and then have you tell me what the longest name in that object is. Okay, it's gonna give me back an answer. It's gonna 100% definitely give me back one string, right? And so the answer now becomes, right, because if I look at the way my function is written, right, I initially start longest name as an empty string. I eventually replace it with something, which is another string, and then I return that. So I know at every single juncture I'm going to be getting back a string. And so if I make a variable here called, let's say, call it inner obj longest name, a bit wordy, but hopefully it gets the name across. Actually, oh yeah, inner obj longest name. Now I can actually just do what I did here and do a quick comparison of these two. Oops, sorry. Okay, except now I'm no longer comparing key.length to longest name.length. I'm comparing inner obj longest name.length to longest name.length, right? And here, if I reach a scenario in which this inner obj is long, so if the longest name in the nested object is longer than the longest name I've seen so far outside of that nested object, then I'm going to replace it. And at this point, I think I'm pretty much done. And the reason why, just so you know, just looking at the test code, it looks like all the values are either objects or nulls. If the objects were also strings, so if this is like David, then we will also need to say, okay, how do we handle it if the object isn't if the current value isn't an object? What if it's a string? Then we need to do this comparison one more time. But just here, because all the values seems to be nulls, then we can say if it's not an object, then we'll just ignore it because we're going to assume that it's either a null or an object. And so let me just double check this to make sure we're on the right track here. Cool. Okay. So, like, if you notice, like, this actually isn't like a ton of code, right? Get longest name is we initialize it to be an empty string. We have our for in loop here. Here we just check the key against the longest name. If longest name is key is longer, then we change the longest name. Here we extract the value out. Here we check to see if the value is if the current object is if the current value is an object. If it is, then we call this. We get back the string value, and all we're doing is comparing that string value to the longest name we've seen so far, right? That's it. If I was to write this in probably shorter and cleaner code, it will probably be around like a dozen lines tops. So like writing a lot of code is not the hard part here, right? The hard part is kind of thinking through it and being like, okay, I understand what my function is trying to do and what I'm trying to return out of it. So I will share this link with you guys. I mean, this actually might be pretty close to identical to what the solution code just might be. So I'm not sure how helpful it is in this state. But we have the video, so you can rewatch this again if you feel so inclined. But any questions here?
Well, it's definitely more helpful with you explaining it than the solution alone, for sure.
Yep. Thank you so much.
Yeah.
Right. And I'm sorry if I like pushed some of you really hard on kind of explaining your thought process, but I was telling one of the groups, right, like that's how the interviews are going to go. Like in most job interviews or in most programming interviews, they actually care a lot less if your answer is like right or wrong off the bat. They'll ask you to kind of walk you through their code, and if you're clear on your thought process and you're walking through it, if your answer is wrong, at some point you'll figure out that you're wrong. And then they'll know that not only do you understand what's going on, but you're also smart enough to recognize your mistakes really quickly. And honestly, like that counts for a lot. I've done plenty of job interviews where if someone just gets it right on the first try, you're not sure if they've seen it before, you're not sure if they're super smart, and it's kind of like, oh, okay, cool, you got it right. Like, there's not much to talk about. And usually interviews are structured so that there's always something to talk about. Like, there's always edge cases you probably didn't think about. There's probably also like multiple ways to do a problem, and so like, when you talk about code, like a lot of times I think when we talk about code, we are able to be ambiguous and kind of get away with it. But once you start typing it out, like there's no ambiguity, right? Like you kind of need to know exactly what you're doing at every step. And so that's something that I really encourage you to practice more around. Is that like don't just think like, oh, I'm just gonna this hopefully does this thing that maybe I saw it do one time on a slide. Like make sure every line of code you're writing, you absolutely understand why you're doing it and kind of what the basis for it is. Cool. Are there any